Rand McNally, as they start thinking about how to build for the mobile device and in particular for iPhones and Android, they're realizing that they don't really have the talent. They're not really positioned well for looking forward. In a lot of ways, they're positioned for like legacy jobs, and so they're actually able to adopt some of our technology as the basis for driving innovation inside there. Happy to get into that a little bit more down the road. Oops. This is a demo of a few different APIs on the Mapbox side. So not only do we have base maps, but we have a directions API. We have something called Turf, which I'll get into a little bit. And then we have all these sort of UI elements that you might need. Like you see the kind of the zoom in and zoom out piece. You see the markers on the map. And all these lines. So we've got polylines on the map. We have an item sort of moving along the map. And in this case, we're looking at a dispatch service for couriers in New York City. And this is exactly the kind of application that developers are building with Mapbox. For instance, Instacart is a customer where they can actually not only power user experiences for their end customers, so in the mobile apps that you and I would use, but they can also use it for back-end services. So we know that Uber, for example, does a lot of data visualization with Mapbox, in addition to using our GL SDKs for Android and some other things. So a good example of kind of those APIs coming together, and you're seeing base maps, you're seeing directions requests, and then you're seeing this map being updated with a marker as the object is moving along and kind of reporting its location. This is another customer. It's Strava. I don't know if you all know Strava, really popular cycling fitness trafficker, specifically for cyclists, but also runners and hikers. This is a snapshot of San Francisco's iconic. You've got the Golden Gate Bridge here, and then this really beautiful climb that somebody did up Hawk Hill. And Hawk Hill is a really gorgeous spot to kind of turn around and look at the city. You've got a really custom base map, and you see, in this case, you see terrain data. You've got these contour lines, which are marked in certain intervals. We have trails popping out in yellow. You've got the red polyline on top of the map based on the branding of Strava. And then on the top sort of third of the map, you actually are seeing an overlay of elevation. And that's querying an elevation API and returning the elevation as part of the route, and so you can actually scrub across the polyline and see exactly what the elevation is. And this kind of visualization, which we all are now kind of accustomed to, requires a number of different APIs, right? So they're hitting a bunch of different Mapbox APIs to produce this and returning a result that's really seamless and integrated to the Strava application. So, one thing we often talk about is that Mapbox is really a platform. We are not going to be a tool that consumers use. Like, we're not building a tool for consumer applications specifically from Mapbox. You're never going to have a Mapbox app on your phone, but you might actually have a dozen different apps that use Mapbox as part of their part of the services that they're using internally to create the experience that you like. One area that I've been working a lot in the last year or so has been working with UAVs and drones, and kind of on the raster side, working with companies that are trying to produce really great user experiences in that realm, which is pretty unexplored at this point. I mean, we're hearing a lot of news and people are pushing into the space, but it's been kind of slow getting off the ground, no pun intended. This is a news piece on Vanuatu. There was a cyclone last March, and there's a team called the Humanitarian UAV Network that went out and collected a bunch of imagery using drones. So they flew over with quadcopters and fixed-wing drones that were capturing imagery at something like 5 centimeter resolution. And this is a post-event. And then what they would do is go in and actually allow people to mark locations based on the damage that was caused at each spot. Right? So you have this imagery browser, and then you have the ability to draw and interact with that data on the map. This involves a couple different Mapbox APIs. So the folks that were going out and flying were collecting imagery and then processing it with their own imagery processing tools. And there are a couple companies out there that do a really good job. One is called Pix4D, if you haven't heard of them. Another one is Agisoft. very popular tools for drone companies and users. And then at the end of that, you spit out, you go in with a flight plan and a bunch of JPEGs, and come out the other end with a geotiff that's been orthorectified and is ready for use with whatever tool you might use. It could be Esri, it could be ArcGIS, it could be Mapbox, it could be Boundless, something else. And in our case, what you can do is actually just upload that to Mapbox. We have an upload API that can take up to 10 gigabytes of geotiffs at a time, and boom, we actually tile that out as a web map that can be used with all of our other APIs. So the ability to draw on the map, the ability to do geospatial queries, the ability to overlay road networks, for instance. If you wanted to take our road network that is dedicated, we have for instance, we have a satellite layer of just road labels. You could actually overlay that on top of this drone imagery, and so all of a sudden you have a lot of context that you wouldn't otherwise have. You can pan and scrub across the imagery and see what's happening in that context. This is just another example. Same idea, right? In the middle, I don't know if you can see my mouse, but in the middle of the image we have this quarry. You can see it's kind of like a carved out image. Around that, we have two different sort of satellite imagery sets. We have a road network for this quarry, and one of the cool things is that this is fully interactive. It's a web map, but it also allows you to run queries right in the browser. So when I play this GIF, I can zoom in and out, and then I can actually select the draw tool. So I can also see the DSM, so there's a surface model that's baked right into this map. I can see contour lines that came out of the drone flight. And then I can select the draw tool, draw a polygon on that area, and immediately return the exact amount of material that was removed from the quarry. So I'm just going to play this again. It's a pretty cool visualization. You've got the visual data, you've got the non-visual data, you have this interactive layer where you can draw on the map. And then what we're doing is we're saying, okay, I've drawn on this area on the map. I'm actually going to query points along those lines and interpolate the total volume that was removed from the quarry and present that to the user in a 3D model. I'm going to pause there because it's a lot of stuff. But when we show this to people at, for instance, the California Office of GIS or Technology, it blows their mind. Because they're sitting there saying, well, I would love to show something like this to decision makers or to the governor or to whatever, but for me to do this would actually take linking together 5 different tools and data sets and techniques and a bunch of custom analysis and whatever. Whereas we're saying, look, just throw this up in the web browser and you're good to go. To be super clear, we are not a GIS consultancy. We're not going to tell you how to measure the volume, which units to use, and how to read the results of this, but we're going to give you the tools to be able to actually do that yourselves. This is Turf. So Turf is one of the tools I wanted to mention. It's actually an open source library for GIS, either in what we call client side, so either in your browser or on the server side using Node. Node is a JavaScript framework, and it includes something like 60 different little code snippets for running different GIS queries. So a lot of the stuff that you're probably doing with ArcGIS can actually be done for free on the web using this toolkit. It's on GitHub, it's open source, and the person on our team that built this basically said, look, I really value a lot of these GIS queries and the analysis that I used to do in my job as an analyst. I don't want to have a license for any of the Esri tech, and I also want this stuff to be accessible on web and mobile. And so he basically just rewrote the entire thing in JavaScript the way he would want it. And I just have highlighted a few different parts of the documentation here, but I encourage you to check it out. It's like 60 different common GIS routines that you would want to do. One of the cooler manifestations of this, in my opinion, is this bike share visualization. So this is a web map that allows the user to, I want to pause it. So what we have on one hand is the user's location. It's like a little person. On the other hand, we have our destination, this little star. In between, all these green dots are capital bike share locations. So in DC, there's a bike share program Each station has a unique identifier. Each station also transmits the availability of bicycles to that spot. And then the green lanes that you see on the map are individual sort of bikeways, right? So it's a custom-based map. It has a data overlay for the locations of the bikes. And then as we actually navigate around the map and drag this person, we can say, okay, if I'm this person and I want to get to that destination using capital bike share, what do I need to do? Right? I'm going to have to walk to the station, then I'm going to want to know how to ride from point A to point B, so to the other station, drop the bike off, and then walk to my destination, right? And this tool will allow you to use turf when you select the user location to say, what is the closest location to me based on all of the items on the map? You select that, then you make a directions API call to say, how do I get from point A to point B? And then you make another directions API call to say, okay, now that I'm walking, show me the walking route from my bike share drop-off spot, getting me to where I'm actually trying to go. So I'll just play this. So I'm moving. You can see me moving around the person. It's telling me the ETA, which is pretty cool. And then as I move around, I can actually toggle a view here that's going to expose to me the elevation along the route, which is amazing, right? So we're using the Surface API, a third API here, to actually say, well, that's great that you're going to ride for 32 minutes, but like if I'm going to work or I'm going to Capitol Hill and I have a meeting, I want to know, am I going to be like sweating when I get there, right? Or is it actually all downhill? And this is an application that takes all those APIs, combines them together, and puts them into a user experience that's really simple and straightforward and kind of fun to use when you look at the elevation profile. Let's see. That is the, that's the last slide I wanted to share with you. I wanted to kind of leave you with this particular visualization. It's on our website. We blog a ton. I would encourage everybody to check that out and just kind of see what we're up to and see if any of the stuff we're building would be useful for you. So I'll just stop there, and I'll be happy to talk to any questions people have.
Well, I have one question to start, Paul. Yesterday we talked a little bit about APIs and base maps and the kind of data that people like Mapbox, like you guys, are collecting to be able to call on to do all of this. And so I'm wondering, I mean, obviously with this application, you're looking at road maps and bike paths and you're looking at elevation. I'm curious, are there certain sort of base map attributes that Mapbox is building out that you think are really unique to Mapbox?
That's a good question. So can you just do like a show of hands? How many people know about OpenStreetMap? Okay, so most if not all people. So we're just huge fans of OpenStreetMap, and what we do is we not only do we contribute to OpenStreetMap, so we have folks on our team, including a small team in globally. We have folks that contribute to OpenStreetMap from our office in DC. From here, we have a small team in Bangalore. We have a small team in Peru. And we work really to improve the base map because it's a core part of the product that we put out into the world. So we approve the map. We then actually take a feed of map data from OpenStreetMap, and we monitor on a minute-by-minute basis what's happening in terms of differences to the map. We publish that out as vector tiles, and then that's available to all of our customers within like 10 minutes. So all of you can actually be on your laptop right now if you've had a laptop open, and trace the building of where we're building here on campus, and then 10 minutes later we'd be on the Foursquare map, which is a pretty amazing thing, I think. And it's a testament to the strength of OpenStreetMap, and it's also a testament to the really data processing pipeline that we've built on our back end to take this data and produce it into a really usable and fresh map. So that's kind of one key part of this. OpenStreetMap is fantastic for roads. It's really great for parks. It's really great for some building footprints in areas. Some things that it lacks right now are some of the metadata around additional context that's really useful for applications. So, for instance, POI names, like not something that you see a ton of, right? POI, let's say it's a place of interest. Let's say it's like the Middlebury rec center, your gym, right? But metadata associated with that could be not only the address, but when that place is open, what kind of equipment they have, what access looks like. Is it handicap accessible? Is it not? And a lot of that data is actually pretty sparse on OpenStreetMap, unlike something you'd see on the commercial side, like Google, right, where it's just spent a ton of energy collecting that data, soliciting information from customers, also listening to customer data and pulling information out of their GPS tracks and that kind of thing. So that's one example in terms of like POI, the information where we're interested in building, either building that capacity on the OpenStreetMap or building our own data set. Another area that might not immediately jump to mind is, for instance, like roads. Like if I see I-89 going through Vermont, how am I going to know what the speed limit is, right? A lot of times that data is actually not included in OpenStreetMap, but it's super useful to somebody navigating on their phone, and it's the kind of data you want in Waze, it's the kind of data you want in any navigation app, so you know if you're going over the speed limit or not. A lot of that data is not existing in OpenStreetMap. So speed limits, another good one is turn restrictions. Like for example, here in San Francisco, we have a number of streets where you just can't turn left between like 4 and 6 p.m. And that's huge, again, for navigation apps. It's just one of those small things that will make or break the experience. And in navigation, I'm sure all of you, if you've been like driving, somebody, Google or Apple or whatever gives you the wrong directions, you have zero tolerance for that kind of thing. So we're investing a lot actually in detecting that kind of data. So using what we call probe data. So if an app that's running Mapbox is sharing data with Mapbox, we could see, for instance, that between the hours of 9 and 4 p.m., 5,000 people made a left turn on Market Street. And then from the hours of 4 to 6, like 3 people made a turn. Well, probably good to flag that as an area for us to look at in terms of a turn restriction. And the same thing can be done with speed limits. The same thing can be done with adding POI density to the map. So for instance, if we know that 500 devices or probes are sort of at rest on a street corner at a given time period, it's probably a good indication that that's a restaurant or business of some kind. And if it's not on the map, well, we can actually compare the two and say we should probably add this to the map. So we do a lot of that kind of work. We also work, this is all like pretty hardcore data work. We do a lot of work with, actually we publicized a lot of work earlier last year with Runkeeper, which is another fitness app where it's like a cell phone app. You go out for your jog, just like any of these, like Nike Plus, Strava, whatever. Their users are really great for helping us figure out where there are trails, right, that are not actually mapped that well. And so actually today, if you use a Mapbox map, like the Strava map, people actually prefer our maps for outdoor use cases over something like Google or Apple, just because the density of trails is a lot better. And then if it's not, like you can throw a GPS on your bike and go ride your mountain biking trail and add it to the map, and it'll be out there the next time you go ride. So I think for us, the feedback loop is really important. Along with all that freedom and flexibility, you also have to think about the downsides of it and the risk around vandalism. So we do a lot of work to lock down certain data sets, like the border of Ukraine and Russia. Like if you don't pay attention, that will change 5 times a day, right? In OpenStreetMap. But we actually can lock that down to be sort of a global map that most of our customers are going to want to use. So those are a few examples of like where we're working with data.
So interesting. All right, here's questions. Come on up. I want to ask you a question. Yeah.
So like kind of going off what you just talked about, like are there any privacy concerns? Like do people know that you're just using their data that's on their phones? Like are there any privacy issues that come about with that?
Yeah, there are huge privacy concerns around that. So something our team has invested a lot in is both, well actually let me just back up. There are always, one of the things I run into a lot is there's always like an angle on the business side, there's an angle on the technical side, and then there's a legal angle. For any problem, like it's just a useful framework for any problem I'm going to run into in business. And so on the business side, we are building the best base maps possible. Right? So our goal, our stated goal, and our promise that we make to developers is we're going to put the best base maps in your hands, and if you don't think they're the best base maps, we're going to help you improve them. So that's our goal there. On the technical side, well, actually, let me go to the legal first. On the legal side, we don't want to have data in our hands that could be considered private data, so what's commonly referred to as PII. For example, we don't really want to know if you go for a job, where the start point is, where the end point is, and to see that for every week for a year, and then just be reduced, so that's where you live. And oh, by the way, you also go to campus every day, so you're probably a student, but we don't actually want to know any of that stuff. So what we do from a legal perspective is we ensure people that we are not storing PII. We're not going to actually, we're going to put some protections in place. We're also going to require a warrant. For instance, if somebody came to us requiring that we turn over data, we have some legal protections in place. And then just coming to the third angle, sort of the technical angle, our team has worked really hard to ensure that we have this data processing pipeline really finely tuned so that, for example, in the case where you're running, like we actually chunk up road segments, GPS tracks into little small segments that are then stripped of any data. So we don't know what app they came from, we don't know anything about you in terms of your demographic. We strip out all the identifying data, and then we throw it into a much bigger mix of data so that it's not possible for people to kind of reverse engineer that and figure out what's going on. We also have really hard time limits in terms of how long we will store data. We have encryption in place. And then one thing that kind of touches all of this is that we actually require developers using Mapbox to include in their application an opt-out notice, allowing end users of their apps to say, actually, I don't want any data to be shared with Mapbox, even if it will improve the map. I don't want to share that. So we actually require our customers to do that, which is really uncommon. And if you think about Google and Apple, they are just collecting this data all day long and do not actually give you that much of a choice in terms of sending it, not sending it, what apps have that control over it. And we're actually trying to just bring that right to the front of the conversation and say, if you're going to do this, you need to provide your customers with a way to opt out of it. Yeah, that's a great question, though.
Yeah. Come on up.
You talked a little bit about the application of Mapbox for like disaster-related things with a cyclone. What kind of other, I guess like I'm really interested in the NGO applications of programs like this. What are people doing with Mapbox in that world?
Yeah, cool. Yeah, it's an area that's been really important for many of us going back years and years. So starting, I mentioned the Afghanistan election, but going back well before that, the team was working with the World Bank and USAID and others. That's how I got my start working professionally. And today, what we do, we actually don't have like a formal, it's kind of interesting. We don't have like a CSR or corporate social responsibility focus. We don't have like an arm of our company that does something. We don't have like a press team that goes out and talks about our good works or any of that kind of stuff. But what happens is like anytime there's an event that affects a lot of people, folks on the team essentially turn their energy towards working on that problem. So when the cyclone hit Mexico this past fall, folks were immediately hopping into tracing, for instance, tracing an OpenStreetMap to make sure that bird networks along the coast were properly mapped so that supplies could be distributed, and so that logisticians with different support, Red Cross and other kinds of response teams could actually figure out how to get to these people. And this happens a lot in areas that are sort of in particular are vulnerable in the sense that there might not be a lot of economic activity that would draw the interest or the attention of somebody like Google to go map the area. But there might be people living there, and for us, with OpenStreetMap, the goal is to map areas of population. And so we can actually, in the run-up to an event or after an emergency, we can actually very quickly map an area in collaboration with a lot of different folks in the community. So I don't want to give the impression that we do this alone. We work with humanitarian OpenStreetMap team. We work with a bunch of other folks. The Red Cross does a lot of work to map areas and then to analyze the results. So, for instance, in Nepal, right after the earthquake this year, we spent a lot of, folks on the team spent a lot of their time mapping, but also using tools like Turf to produce shape maps to understand, to compare intensity of shaking with density of population, to look then at those locations specifically and say, okay, is this area really well traced, or do we need to ask a team from Humanitarian OpenStreetMap to go in and add context? So that's a little bit of what we do internally. There are many different folks in the humanitarian space and the NGO space that use Mapbox kind of professionally. So a good example is the Red Cross. Another one is the NGA, which is the National Geospatial Agency. Bill and Melinda Gates uses OpenStreetMap. We've got just a lot of users around the world that are using Mapbox to take on some of these really hard humanitarian challenges.
It's very cool. All right, what else we got? Oh yeah, can you talk a little bit about the deal that you guys just struck with MapQuest and what that partnership looks like?
Yeah, I'm happy to. So I worked on that deal, and it was kind of crazy. So, I was talking about like Rand Valley and National Geographic and whatever, these companies that have been making maps for a long time. MapQuest is like the original, it's like the OG online map platform, right? Like they started actually in the 60s building maps, and then were one of the first platforms out there for people to get directions from A to B. And people still use that, which is surprising, right? Not only people in this room, but like your parents or your aunt or your uncle or whatever. 45 million people use MapQuest every month for navigation. So it's a huge online property. It got bought by AOL. AOL just got bought by Verizon, and along the way, MapQuest basically decided, look, we want to have like a first-rate mapping experience. So we want to have a really good competitive product to go against Apple and Google and everybody else. So they decided that, and then they looked around and they're like, we just don't have the talent to actually pull this off, right? When you're looking at competing with Google, Google has thousands of people working on mapping. Mapbox has 130 people total. But we have some great technology. MapQuest has even fewer people working on mapping, and now actually a lot less. But they said we just can't do it ourselves. And so they actually approached us and said, what would it look like for Mapbox to provide all of our base map services and the map tiles? We said that's great. We have really scalable infrastructure. We can accommodate any kind of usage that you have in mind. We worked on a deal, and in the process of working on the deal, it came out that, and this is all public information, that MapQuest has a license to use TomTom data, which is a commercial data set that's available for global streets and roads and whatever. And they said, look, we really like this data, and we're going to use routing that routes along this road network, and so we want a base map to use that data instead of using OpenStreetMap data. And for us, it was just kind of an interesting moment because we're really big proponents of OpenStreetMap. We actually think the quality is on par, if not better, than the commercial data sets. But in this case, we got this request, and we're like, I think we can do this. We actually realized that we could put together a sort of parallel processing stack to take TomTom data and TomTom data updates, turn those into vector tiles, and then use our exact same infrastructure to power a global base map from another data source. And so that was a pretty cool deal, both on the from a lot of perspectives. I think one being the scale of how big they are and how much traffic they do, just massive. They still have, I think, about a third of the US map traffic, which is pretty wild. And then also just wild to work on a data problem that was that sort of deep and complicated. And yeah, it was a really fun one.
Oh, that's really interesting. I'm surprised anyone uses MapQuest anymore. All right, what else do we have, guys? Yeah. All that.
Hi, Paul. So we were talking a little bit recently about your big acquisition of imagery from Digital Globe. And so my question is, which generally parts of the world did you purchase imagery for, and how did you make the decision? And then the second part is kind of like, do you have a couple big clients specifically that were looking for this type of thing? Or is this more of like a business guess where you think there's going to be demand for this like high quality, recent imagery on a big scale?
Yeah, that is a good series of questions. Let me know if you want to work on those with us. So that's a really hard one. First of all, to compete at a really top level and to compete globally, you have to have a satellite-based map. So we knew that we had to have a really high quality product. We bought a bunch of Digital Globe imagery a couple of years ago, and then we were continuously updating that imagery kind of on a small scale, going like location to location, and also using open data. So we use, just to give you an example, Denmark somehow has like an amazing, it actually makes sense, but Denmark has an amazing national survey. It's like 10 centimeter aerial survey for the entire country that's open. So you can go and grab this open data, and we started going around the world and looking for open data like that and injecting it into our base map right alongside some of the other data sets. But one of the the key things here is that you have to have a satellite-based map, period. You also have to have a map that is updated frequently. And it's really interesting to me to see how those use cases, I love talking to customers about how they use Mapbox satellite and what they expect from it. And just to give you a couple of anecdotes, satellite imagery is really important to Strava users, right? So like people who are going cycling, they actually want to be able to toggle on and off between a street view with terrain and a satellite view that allows them to look for attributes of the road. Like they want to know what kind of road it is. They want to know, is there like a huge stand of trees that I'm going to make a right turn at? And it's really important to them. So, for example, in Norway, like outside of Oslo, I think we did not have good quality imagery from our original purchase from Digital Globe, and that was one of the locations that we wanted to replace. And using that as an example, we knew that, for instance, like we wanted high resolution, we wanted color imagery, we wanted cloud-free imagery, and we wanted imagery in areas where there was a population density, and in particular, people who would use our apps, right, like apps that are using Mapbox. And so our imagery team, and we have a dedicated team that works on satellite imagery and aerial imagery, they looked at that example and then proceeded to do a global study, essentially looking for examples like that, where either our imagery was deficient or we knew we could improve our imagery to meet the market demand for it. And they used Turf, and they used a product called Tile Reviews, which is an open source library that allows you to run really large scale analysis. And they actually produced a map, obviously, but no surprise, of all the locations in the world where we could really stand to improve our imagery, and we knew that our customers were really happy about it. And they looked at all the conventional stuff, like the imagery is low res, or it's black and white, or it's a giant cloud over a certain city in Central America, or whatever. And then they also added a lot of really interesting metrics. So looking at, for example, we have access to a data set of Wi-Fi router locations around the world, and being able to actually overlay that against holes in our imagery and figure out, okay, is there enough density here, enough internet access that would make sense to upgrade the imagery? And then taking another step further, being able to say, hey, let's look at density of tweets around the world. So looking at the Twitter fire hose and saying, give me all the geographically tagged tweets, and then show me any location out in the world, and draw a buffer around any location that falls within a hole in our imagery, so something that's deficient in terms of quality, and has more than 5 tweets in the last month, right? The world is just fucking huge, right? So you can't actually go around the whole world and figure out, okay, I want imagery here and there and that other place. And also as a startup, we just don't have the budget to go to Digital Globe and be like, give us 100 million square kilometers of imagery. So we had to get really scrappy and use a lot of our own tech to be able to figure out where are people going to really want to see this imagery improved. And then look at, again, like what Digital Globe can offer us. Like they have a product that I'm really excited about called the Metro product, which is, I think now over 1,000 cities around the world that are 30 centimeter resolution imagery mosaics. So they're using the Worldview 3, which is their latest satellite, to actually produce a super high-res mosaic that is aesthetically pleasing, but also really fresh, given that Worldview 3 just went up last year. And so, we were able to kind of take our needs, pair it with what they can offer, and then put together an order that has a lot of quantitative data supporting it, and also allows us to tell the story of how much work we put into making this a great base map.
All right, we have time for maybe one more. I do have one, but I want to.
Hi, my name is Bianca. I've been messing around with Leaflet a little bit, and I want to know where that's incorporated into Mapbox, as well as what your current partnership is with Apple. So 2 different entities there. Leaflet, Apple.
Cool. Let me start with Apple. We don't really have a partnership with Apple. We don't have a relationship other than the fact that our maps work on their devices. So that's probably the best way to think of it there. We compete with them when it comes to developers making choices about what kind of maps to put in their apps. So the developers building for iOS can kind of easily include an iOS and Apple map in their application, and we would like that actually to be our map instead. So we compete with them on that front, and it sets a really high bar for our quality and ease of use on Apple. So that's an area where we're sort of both competing and also really inspired by what they do. The second question around Leaflet is a great question, and we get this a lot. People are like, I'm building a web map. Leaflet seems like the go-to map thing. What do we need you for? Right? Or like, how do we use you with Leaflet or whatever? And it's pretty cool. So Leaflet is a library, a JavaScript library for building web maps that gives you, it takes all of these images that you have, all these map files, combines them into an interactive map where you can navigate, zoom, whatever. It has a lot of the standard UI elements, so like the zoom in, zoom out, and all the rest of that. What Leaflet does not have is underlying map data. Right? So it's really just a JavaScript library that a developer will bring onto a website to make an interactive map, but you still need the map data, you need all those tiles, all the map services to actually bring that to life. And so that's where we actually produce all of the map tiles, the map services, and on top of that, we produce something called Mapbox.js. It's a JavaScript library, it's open source. It's a library that pairs with Leaflet in the sense that it's actually a plugin for Leaflet. And it allows you to, like with 3 lines of code, create a Leaflet map on your website using Mapbox data, Mapbox UI elements, and all the rest of it, without having to grab stuff directly from Leaflet or try to combine the 2 yourself. And so it's an option that developers have, and we think there are a lot of benefits to using it. For instance, I'll give you like one really concrete example. Mapbox.js will detect the screen resolution of the device, and if it's a Retina screen, we will actually serve 2x tiles, so tiles that are twice as big and twice as sharp on high-resolution displays. That's like a feature that just comes with using Mapbox.js, and there are a bunch of others, like we just handle attribution for you, we do a lot of different stuff. So that's kind of how that relationship works. The founder and creator of Leaflet, his name is Vladimir, he actually works on our team. So he works with us now, and he continues to sort of manage the Leaflet, the product, and also help us make sure that Mapbox.js is the best sort of plugin possible.
So I know we're pretty much out of time here, Paul. I just kind of hoping you can tie all of this in a nice little package for us. You mentioned when you started out talking about market position and Esri and Google and a lot of these other entities that are out there. And I'm wondering, last year when Google announced deprecation of GME, and sort of, I'm wondering if you could really quickly just touch on that and sort of what that meant to Mapbox, if anything. and then potentially just share with us what you think about Mapbox in the geo market as a whole. Do you feel that you're a disruptive company, and if so, how?
I feel like everybody else is supposed to call you disruptive, right? I'm supposed to call yourself disruptive. I wouldn't think this, but I know what that's about. I think we are producing a lot of technology that is changing the way that people interact with maps, period. And that can be described as disruptive. A lot of this technology is available, for instance, in limited ways from other companies. So, just to give you an example, Google has GL maps on your iPhone or whatever. You can interact with it, you can twist it and tilt it and all the rest of it. But no developer can actually grab that map and customize it and insert their own data and make it like the exact thing that they want for their application. Right? So it's sort of available from them, but none of the interactivity or the functionality or the customization that you might want is available. So that's a way that we are kind of constantly pushing forward. Same thing with creating this vector tile spec that Esri is adopting. Like we are just building tech and we're releasing the open source world and allowing folks like Esri to kind of piggyback onto that. In terms of like our vision, I would say we want to be able to serve this really broad need for not only like GIS type functionality, like analysis stuff. You might want to do a buffer or whatever. But we want to be the map and the map service that's inside of everything, right? So when you open your phone and you look at the weather and it tells you, okay, I'm in Middlebury, Vermont, that's a query that's being made against an API somewhere, and we want that to be the Mapbox APIs. And so whether you see us or you don't, we'd like to be kind of the geospatial services powering all that kind of stuff. And that's very much what we're working on now.
Awesome. All right. Well, thank you so much for your time. This was awesome. I hope everybody else. This was actually really cool for me to hear. I know you work a lot with Alistair, but I haven't had a chance to kind of get some of the more in-depth stuff. But yeah, this was great. I think the class had some good questions. Thank you for taking the time. And
my pleasure.
Yeah, hopefully we'll chat soon. Take care, Paul.
Thanks, everybody. Appreciate your questions. Take care.
What'd everybody think?